For 13 years, the Cassini spacecraft explored astounding worlds, Saturn and its moons.
We discovered things we never imagined.
All of these strange, bizarre landscapes, geysers erupting out of moons.
We were so stunned by the images. I mean, people were just going around in shock.
But Cassini started running out of fuel.
Scientists at NASA had to decide what to do next. And the answer was actually pretty spectacular.
Cassini goes where no spacecraft has gone before. A death flight, revealing the deepest secrets of Saturn. Out beyond Jupiter lies Saturn, a planet circled by multiple moons and rings. It's like a miniature solar system.
Imagine having a mission with the power, the instruments, the capability to explore all aspects of the Saturn system.
That mission was Cassini. It would become our eyes and ears in the Saturnian system for over 13 years. But by September 2017, Cassini's almost out of fuel.
Cassini has been orbiting Saturn and studying the Saturn system for over a decade. End the mission. We're going to lose control soon. So rather than let it just go derelict, we headed into Saturn. Go out with a bang.
The Cassini team goes for broke. They program the probe to head straight for the planet.
How cool is it to sort of sacrifice everything you've got to sort of learn your last bit of information and then crash and burn?
We are in the atmosphere.
As Cassini was careening toward its death, it still had instruments that continued to work, and as each instrument died, there was still a set sending back data and information.
Cassini wasn't designed to plunge through Saturn's atmosphere. No one knew how long it would last before burning up.
I remember sitting in a room with my colleagues on Cassini and watching that radio signal, that sharp green peak that told us Cassini was still linked to the Earth.
We could monitor the atmosphere as we flew into it, and right up until the last, it was sending back signs.
I was really impressed by how long Cassini lasted in the Saturn atmosphere. I mean, go NASA engineering.
As Cassini plummeted down at 77,000 miles per hour, it was bombarded by gas molecules in Saturn's atmosphere. Friction started tearing Cassini apart as it struggled to maintain contact.
As the antenna turned away, we actually saw a secondary little peak, and we thought, okay, Cassini, hang in there, keep fighting. And then just that green flat line.
Just heard the signal from the spacecraft has gone and in the next 45 seconds, so will be the spacecraft.
Cassini's heartbeat was gone, and we knew the mission had ended.
It just vaporized in the Saturnian atmosphere, and so it has become a part of Saturn itself.
Cassini's death plunge was just the last of a series of daring dives.
Prior to ending Cassini's mission by sending it into Saturn's atmosphere, NASA's engineers and scientists came up with an idea. Let's do dives into the region between the tops of Saturn's clouds and the innermost area of Saturn's rings.
Beginning in April 2017, Cassini ventured between Saturn and its rings 22 times. Scientists call it the grand finale.
On these dives, Cassini got closer to Saturn's cloud tops than any spacecraft ever had before.
Saturn is an enormous ball of hydrogen and helium, a gas giant.
Fundamentally, it's a really very different kind of planet than we're used to in our everyday lives.
Cassini snaps close-ups of the planet's gaseous surface. The pictures reveal a turbulent and stormy world.
We think of some storms on Earth as being particularly violent. If you've ever been in a hurricane, that's not a fun place to be. But the storms on Saturn, the wind patterns on Saturn can make that look like a mere breeze in comparison.
On Saturn, one storm stands out. Its location is marked by a distinct shape.
One of the really weird things is that as the bands go around Saturn, they're all circular until you get to the pole. And then there's a hexagonal band up there. No one expected that.
During its lifetime, Cassini took multiple images of the hexagon.
Whenever we posted an image of the hexagon, the hits to the website went through the roof. I think people thought it was so mysterious.
When I first saw this, I was blown away. I mean, who could imagine having something this regular, almost geometric, on the atmosphere of a planet? It's really just phenomenal.
In 2018, Cassini data reveals this hexagonal storm could be a towering structure hundreds of miles in height.
It's this gigantic structure. It's many thousands of miles across, and right in the center, right at the pole, is this sort of permanent vortex, a permanent hurricane. So it's kind of a creepy eye-like thing staring back at us.
Each side of the hexagon is as wide as the Earth.
It seems artificial. How do you get a hexagon-shaped storm or cloud structure on Saturn?
Scientists think that Saturn's spin interacts with the air currents to create this symmetrical shape. But they don't know why it's lasted for decades.
That's the puzzle. How can you get a six-sided jet stream that's stable for so long?
But while the hexagon's shape is stable, the color has altered. Over 4 years, it has changed from mostly blue to golden brown. The transformation is linked to Saturn's seasons.
The seasons on Saturn are caused by the same thing on Earth. It's the tilt of the planet. And so as Saturn is going around the sun and its north pole is tipping toward the sun, you start to get more light up there.
This sunlight interacts with the atmosphere, producing suspended particles called aerosols.
It actually looks a lot like smog. It turns things more orange. So over time, the hexagon went from blue to orange.
The color change happened during one of Saturn's northern hemisphere summers. But mysteriously, the very center of the hexagon remained blue.
Now, this could have been for two reasons. Maybe the haze never formed in the eye because the eye was shielded from the sun, and the sun is responsible for creating the brownish haze that we see on Saturn. Another reason is maybe the actual vortex is sucking the haze down. Maybe there's something like the eye of a hurricane. There's haze that forms over it, but it gets sucked down into the eye.
But the storms on Saturn aren't the only extraordinary thing about the weather. When Cassini dives through the rings, it discovers rain. Rain falling onto the planet from space.
brand new. How the universe works. Tonight on Discovery Science. I could watch this stuff forever. Brand new. How it's made. Thursday on Discovery Science. This summer, Adam Savage takes us beyond the myth.
Holy cow, everything blows to smithereens.
And he's building the most awesomest things ever.
Kaboom, there we go. Boom, boom, boom. So much fun. Let's blow it up.
Mad Max Battle, Excalibur, Wheel of Death. And it all kicks off with Iron Man.
The first fucking Iron Man suit! Yeah!
Brand new, Savage Builds. Tuesday on Discovery Science.
April 2017, Casini embarked on its grand finale, following a daring new path.
We decided to dive in between the rings and the planet, to go to a place no spacecraft had ever flown before, and make a unique set of measurements.
It was uncharted territory.
They didn't know exactly what they were going to find. There could be stuff there that could have destroyed the Cassini spacecraft.
Instead, Casini encountered something totally unexpected. Rain.
On Earth, it rains quite a bit. We're getting that rain from rain clouds, which are basically just a few miles up. On Saturn, it also rains, but it turns out it's raining onto the top of the upper atmosphere, and that rain is coming from space.
In 2018, Cassini data revealed the colossal weight of the downpour. Icy grained rain hit Saturn at a rate of several tons per second.
It's completely unlike anything we've ever seen. Suddenly we've discovered rain at Saturn, but there aren't any rain clouds. Where is it coming from?
The answer is Saturn's rings.
The first thing you think of when you hear the word Saturn is the rings. They're the most dramatic and unique aspect of that planet.
From afar, Saturn's rings look like just one whole structure. But when you look up close, it's actually a bunch of ice crystals and ice rocks that make Saturn's rings.
The ring material ranges in size, from dust grains to boulders the size of houses.
Saturn's rings are well above the atmosphere of Saturn. They're way out in space. And under normal circumstances, those particles of ice making up the rings would just orbit Saturn forever. But things are a little bit weird.
Something is making these orbiting ice particles fall inward as a kind of cosmic hail.
Material is dripping inwards from the rings and falling into the clouds of Saturn. It's like a rain with no rain cloud, like a cosmic rain trickling in and falling down.
Casini discovers the rain is a mix of different kinds of ice particles, but doesn't reveal why they actually rain down. Then the researchers realized the ice grains were statically charged.
Ultraviolet light from the sun, for example, can blow off an electron, and that gives these particles a charge, just like rubbing a balloon on your hair makes it stick to a wall because of the static charge. Well, if you have particles that are like that, they can be affected by magnetism, and Saturn has a very strong magnetic field.
Earth's magnetic field springs from its spinning molten iron core. Although Saturn probably has a rocky center, it's mostly a giant ball of hydrogen and helium. But deep in its interior, scientists think something much more exotic is going on.
We don't have enough data to know exactly what's going on in Saturn's interior, but we do know the broad strokes.
Within Saturn's interior, extreme pressures and temperatures force hydrogen to stop acting like a gas, turning it into spinning liquid metallic hydrogen.
You've got this band of electrons that can just wander freely through that fluid. So in that way, liquid hydrogen under extreme pressure can act like a metal.
The magnetic field, generated by the spinning metallic hydrogen outer core, pulls the ice particles from the rings.
These charged ice particles are then drawn in by Saturn's field. They follow the magnetic field lines and rain down onto the atmosphere of Saturn.
Casini had revealed several tons of material is raining down on Saturn every second. But how much stuff is actually in the rings? Again, Casini provides the answer.
In the final days of Cassini, we actually flew in between the planet Saturn and the rings. And the gravity data was able to separate out how much mass is coming from the planet and how much is coming from the rings. And the surprise was that the rings are actually not very massive at all.
Even though they cover an area as big as the moon's orbit around Earth, Saturn's rings are 100,000 times less massive than our own small planet.
They're lighter than we thought. There's not as much material there.
The mass of the rings is a valuable clue about their age.
A more massive ring can hold itself together for much longer than a less massive ring. So if there's not a lot of stuff there, it must be younger.
So how long have Saturn's rings been in place? And what's keeping them there?
It's something that I don't even think I could have imagined if I tried.
As Cassini orbited Saturn, it revealed incredible insights into the planet's rings.
The photos that came from Cassini of the rings are unlike anything that I could ever imagine.
If I was an alien visiting our solar system, I don't know what would stand out to me more, the blue marble or Saturn and its amazing rings.
One of the biggest questions about the rings is how old are they? Could something like that really have existed from the beginning of the solar system, or is it relatively recent?
Cassini provided an answer.
The rings could be as young as only 100 million years old. A couple of clues: the low mass and the fact that they're so bright and icy that it hasn't had time to get polluted from all the micrometeoroids and darkened over a long time, like the age of the solar system.
So the amazing thing is that, if you were on Earth about the time of the dinosaurs, there might have been a Saturn in the sky with no rings.
So if the rings didn't form at the same time as Saturn, how did they form? And what's keeping them in place?
To form the rings 100 million years ago, you need to find an object, maybe a comet or a moon gets too close to Saturn. Saturn's gravity tears it apart and forms the rings.
As the object is torn apart, the pieces spread out around Saturn to form the rings. They keep colliding, breaking into smaller and smaller pieces.
Like pebbles on a beach, subsequent jostling and self-collisions between each other will take the sharp edges off of them, creating rounded particles.
From a distance, Saturn's rings appear incredibly thin and almost perfectly flat, but appearances can be deceptive.
One of our last results from Cassini as it took its final plunge into Saturn was as we flew past those rings, we noticed that the rings were actually not a uniform density. That's something that nobody had seen. I mean, you had to get really close to see that, and it wasn't expected.
I'm a ring scientist, and I just love seeing that detail and trying to figure out why do Saturn's rings look the way they do.
There are very intricate structures, knife-edge little ringlets, and almost like the grooves in a record. Begs the question, of course, where do those structures come from?
The clue is hidden within the rings.
There's not 5 rings, there's not 500 rings, there's thousands of rings. There's potentially millions of tiny little ringlets with small gaps between them and sometimes large gaps. And Cassini saw that there are moons embedded inside the rings.
These moons and moonlets seem to be shaping the rings.
When I think about the rings of Saturn, I almost hear symphonies playing in my head. It's all about this wonderful structure and these harmonies, the balances between gravity. So we use the word resonance.
Saturn's moons stir the ring particles with their gravitational pull, creating waves.
There's a special place where the resonance exists. Imagine where the ring particles will go around twice for each single time the moon goes around. It's like pushing someone on a swing. If you push them at just the right rate, they go higher and higher. And these places are where the waves generated.
So there's this ballet, this dance between the ring and the moons. It is one of the most elegant things I've ever seen.
But the rings aren't just being shaped into waves by the moons. They're being held in place by them.
Through gravitational interactions, these moons might be shaping the rings, shepherding them, keeping their flock in a nice tight orbit around the planet.
In 2017, Casini reveals there are more than 1 or 2 moons shepherding the rings. A whole team of moons holds Saturn's outermost visible ring, the A ring, in place.
One of the really cool things that Cassini discovered during its death dive was that there are 7 moons of Saturn that are all working together to keep that ring system in configuration. So it's like the Magnificent Seven holding this thing together.
Of the 7 magnificent moons, the biggest is Mimas. It's 1/8 the size of our moon. The smallest, Pan, is only 20 miles across. Acting in combination, these moons hold all of Saturn's rings in check.
So it's these 7 moons working together, forming the ring system that we see today.
Cassini has truly opened our eyes to the wonder of Saturn's rings and many moons.
Saturn has a lot of moons. I mean, a lot of moons. And they're all really interesting and different.
Coming up with an exact number is a little difficult because it almost changes every year as we discover new ones.
The latest count is over 60 moons, each with a different character. But one has a split personality and a very dark side.
The surge of attention to plastic pollution is pretty striking.
We're back with an alarming new report on the state of the world's oceans.
About 8 million metric tons go into the ocean every year. We're living in a plastic pollution crisis.
I believe we're at a tipping point right now. I've seen more policy change globally in the last 8 months than I've seen in 20 years of my career.
There is hope if we work together. This Earth Day, watch the story of plastic. Wednesday on Discovery Science.
May 2017, Casini was on its grand finale. The probe snapped its last photo of a strange moon 2 million miles from Saturn. Iapetus.
Iapetus was discovered hundreds of years ago, and right from the start, it was recognized that one side of it was very bright and the other side was as dark can be.
This dark and light moon confused Italian astronomer Giovanni Casini when he first spotted it in 1671. It's been puzzling scientists ever since.
So we get there with Casini, and of course Iapetus was a very major target for us because we were interested to know what was with this crazy two-toned moon.
Casini reveals that the answer lies even farther out from Saturn, in the form of another moon.
There's one pretty big but really dark moon, Phoebe, that's outside of Iapetus and is orbiting the opposite direction around Saturn.
Phoebe orbits Saturn 4 times farther out than Iapetus. As it travels around the planet, micrometeorite impacts on the moon's surface generate a cloud of dark dust.
The dust from Phoebe actually creates a large ring.
A ring of dark, dusty material that's drifting inwards towards Saturn, going the opposite direction of Iapetus, which is the perfect material for Iapetus to sweep up in its orbit to create one dark side.
Iapetus has one dark side because it's tidally locked to Saturn. One side always faces the planet, while another side drives forward through the dust.
It's plowing through a bunch of dust that's sticking to the front side, kind of like bugs on a windshield.
Casini discovered this dark dust makes the leading side warmer than the trailing bright side by 50 degrees Fahrenheit.
When you have something that's dark, like the dust on the leading edge of Iapetus, that gets warmer. It absorbs sunlight better. And if it's warmer, then things that can evaporate more easily, like water, for example, tends to blow off the surface.
The front side gets darker and warmer. Any visible ice turns to vapor and makes its way to the colder trailing side, where it refreezes. So the white side gets whiter and the dark side gets darker.
So you have this self-sustaining dark side and bright side, and you wind up with this two-faced moon.
Iapetus's two sides are strange. But Casini discovers that they're not the weirdest thing about this moon.
The weirdest thing is that it is a walnut.
Iapetus has a mountain range that exactly circles its equator all the way around the moon, a mountain range higher than the Himalayas.
These mountains are over 12 miles high, more than twice the altitude of Earth's highest peak, Mount Everest.
It's crazy. It's this huge, crazy ridge on this really strange moon.
How do you form a smooth equatorial mountain ridge around an entire world?
A really interesting idea is that for some period of time, Just like Saturn itself has this gigantic ring system, Iapetus had a ring system as well.
Over time, Iapetus's rings collapsed, falling into a circle around the moon.
As it fell to the surface, it built up a mountain range right below where the ring was orbiting. So that all that material just built up and built a mountain range, ringing the equator all the way around.
Walnut-shaped Iapetus is not the only strange moon around Saturn. Cassini discovered a moon hiding many secrets beneath its icy surface. Enceladus, a moon that could even harbor life. August 2017. Cassini captured 6 images of Enceladus, one of the most intriguing moons in the solar system.
Enceladus is a relatively small moon of Saturn that's pretty easy to ignore, but once you pay attention to it, hosts a lot of surprises.
We've known something was unusual about this icy world ever since the Voyager mission took photographs in 1980.
We thought that Enceladus would be frozen solid, and yet we knew from Voyager data the surface of Enceladus was bright white.
And we could see on the surface that vast tracts of it were smooth, at least at the resolution that we had with Voyager. And that immediately says that there's been internal activity, because that's really on an airless moon. That's the only process that could erase craters.
Scientists suspected something was actively resurfacing Enceladus, filling in its craters to make it smooth and bright. Then Cassini sent back pictures of Enceladus backlit, and all was revealed.
We saw these icy jets shooting out from Enceladus, and everyone was so amazed that a moon so tiny and assumed to be a frozen solid ice cube could be so active.
Jets of almost luminous material spraying out of geysers.
When I first saw a picture of a geyser on Enceladus, I mean, I was floored. That's amazing. I had no idea that that was even possible.
The Cassini discovery of geysers on Enceladus was a game changer. All of a sudden, here's water jetting out. It was like too good to be true.
Cassini revealed the geysers are blasting out liquid water. Enceladus is not a solid ball of ice.
As we got more data from Cassini, we found that Enceladus had a wobble that was too large for a body that was frozen solid all the way through, and that told us that a liquid water ocean circled a rocky core.
Enceladus has liquid water under its surface, and it may very well be an ocean, basically covering the inside of that moon. But where's the heat coming from?
When planets and moons form, their cores are incredibly hot. But they cool down over time. The smaller the planet, the faster it cools. A tiny world like Enceladus, over 1 billion miles from the sun, should have frozen solid by now.
That's what we expected. If things are smaller, then they would be roughly dead and they'd be covered by craters. But Enceladus shows us that that's not the case at all.
How could a tiny moon so far from the sun have enough warmth for liquid water? One idea is tidal heating.
If you've ever played racquetball, you know as you play the game, the ball heats up. And this is because as the ball hits the racket or the wall, it's getting squished and then it relaxes.
Saturn's gravity squishes and relaxes Enceladus as it orbits the planet, heating it like a racquetball. But this alone wouldn't generate enough heat to stop Enceladus's water from freezing. Something else must be going on in the core.
what if the core of Enceladus is actually kind of gravelly? Instead of it just being solid, it's actually made of rocks and pebbles and gravel all put together. Then what happens is, as the tides are stretching and squeezing it, those rocks are rubbing together, and that actually generates even more energy.
2017, a computer model based on Casini data revealed this tidal friction generates more energy than America's biggest power station. Water heated to 194 degrees Fahrenheit rises to the surface. It sprays through cracks in the moon's south pole, creating misty plumes.
As we flew 7 times through and tasted and sampled the gas and the particles, we found salty particles, that the ocean was salty, very much like the Earth's ocean. We found hydrocarbons, methane, carbon dioxide, ammonia. We found the key ingredients for life coming out of the jets of Enceladus. So remarkable.
In 2018, scientists reanalyzed the Enceladus data and found something even more remarkable. Complex organic molecules.
What they found were larger organic compounds than initially thought there. At first it was just dust and water and some basic organics. Now they're seeing more complex stuff coming up from Enceladus's interior, and that asks the question, what else is down there?
On Earth, we find life huddled around hot vents on the seabed. Could the same be true in the oceans of Enceladus? Could these complex organic molecules be signs of life?
My favorite name for them is goo. They're gooey things. And think of life as a collection of gooey-like molecules. Now, that doesn't mean that all gooey molecules are biological, but certainly biology makes use of these complex organic molecules.
Deep in Enceladus's oceans, heat from hydrothermal vents drives chemical reactions, combining simple molecules like methane and hydrogen into longer, complex organic molecules. Complex molecules that could serve as the precursors to life.
What's amazing is the chemistry of that ocean. Everything needed for life is there.
The eternal question is there life in the universe? And Enceladus is a great place to try and answer that question.
And Casini revealed secrets of another moon of Saturn with amazing chemistry. A giant moon with Earth-like features, rivers, lakes, and dunes. Titan.
The second bellow is lifting the tail. And if you lift the tail, the head is going down and saying, cuckoo, hello.
Cuckoos come in various designs, and Ingolf's wife Connie has painted more birds than she'd care to recall.
Many, many, many. Thousands.
And with her decoration complete, it's time to bring the final clock together. The mechanism goes in, the bellows are added, the clock hands are attached, the carvings are fixed.
Okay, that's a finished clock. We did it.
Prices ranged from €200 to 15,000. Because a cuckoo of this quality never goes cheap.
The surge of attention to plastic pollution is pretty striking.
We're back with an alarming new report on the state of the world's oceans.
About 8 million metric tons go into the ocean every year.
We're living in a plastic pollution crisis.
I believe we're at a tipping point right now. I've seen more policy change globally in the last 8 months than I've seen in 20 years of my career.
There is hope if we work together. This Earth Day, watch the story of plastic. Wednesday on Discovery Science.
September 2017. 4 days before the mission ended, Casini flew past one of Saturn's most spectacular moons, Titan.
Here's why I like Titan. Not just because it has a name that means big and strong, which makes you think of me, but because it has an extensive atmosphere that's made primarily of nitrogen, just like Earth's.
Titan's always been a mystery. What is hiding underneath that thick atmosphere?
Viewed through a telescope, this moon seemed little more than a hazy orange ball. Then Casini launched the Huygens probe. It traveled beneath the clouds and sent back images of Titan's surface.
I can't describe how thrilling it was, the landing of the Huygens probe on the surface of Titan. It was like a Jules Verne adventure come true.
The images that you see as you're coming through the atmosphere and the world emerges, and it's this incredible world that looks so familiar. Mountains and these streams flowing into this ocean. Wow.
You might be standing on the shores of a lake, but this lake doesn't look like water. Instead, it's methane. It's much darker.
It's a frigid, bizarre world with geologic features that look familiar, but in a very, very alien setting.
Titan is like a home away from home, just colder by 350 degrees Fahrenheit.
The Cassini mission revealed that Titan is really exactly like Earth in terms of its landscape. In fact, almost a quarter of the body is covered in sand dunes, exactly like what you see behind me.
But Casini reveals Titan's dunes aren't what they seem.
The dunes on Titan are made of something completely different than sand dunes on the Earth. We know most sand on the Earth is made of quartz, but on Titan, sand dunes, it turns out, are made entirely of organics.
Titan sand is made from tiny particles of organic gunk called hydrocarbons.
It's weird enough that we see dunes made of hydrocarbon particles on Titan's surface. It gets even weirder because some of these dunes appear to be facing the wrong way.
Titan's dunes are shaped as if the wind blows from the west, but prevailing winds on Titan blow from the east. Why are Titan's dunes facing backwards?
One idea is that electrostatic forces are holding together the dunes on Titan, and they're creating these strange shapes. So electrostatic forces are the same thing that you see on packing beads if you were to put your hand into them. They're the same thing that are holding these beads to my hand.
On Titan, the dune particles rub against each other and build up a static charge. This charge attracts the particles to each other like tiny magnets.
Well, the prevailing winds near the surface of Titan are actually fairly low speed, a few miles an hour, and they can't blow these particles around very well. But you can get seasonal winds, storms for example, and that could blow much faster, and they could also blow in the other direction.
During storms, the winds on Titan blow 5 times faster than normal, pushing the particles into dunes.
And then they stay that way because the prevailing winds can't pick up those particles and reshape them the way you'd expect. And that's why maybe these dunes are facing the wrong way.
These organic dunes contain the building blocks of life. For scientists, this is a tantalizing hint. Could Titan harbor life?
Here on Earth, there's life that exists in so many extreme environments, so it's not impossible to think that life could have evolved to use the methane and all of the other chemical constituents on Titan.
If life has developed on Titan, it's going to look really weird. It's going to be really different from life on Earth.
To me, there's going to be this wonderful moment in history when we really do have another example of how life can be. And if I had to place my bets on it, I think we're going to find it in the Saturn system.
But Cassini's discovery of potential life sentenced the probe to death.
We didn't want to leave it just indefinitely in orbit because there was this fear that, you know, should there be any earthly contamination on the spacecraft, you don't want it crashing into Titan or Enceladus.
Cassini interacted with Titan one last time.
With a gentle nudge from Titan's gravity, we call it Titan's goodbye kiss. We ended the mission with a plunge into Saturn's atmosphere, vaporizing Cassini and saying goodbye to our friend.
I hope you're all as deeply proud of this amazing accomplishment. I'm going to call this the end of mission. Project Manager, off the net.
Although Cassini is gone, its legacy lives on.
Now we're sifting through all of the data collected, still finding discoveries, putting together the pieces of the puzzle to understand Saturn, the rings, and the moons.
Cassini is going to go down in history as one of the most scientifically productive interplanetary missions that humanity has ever flown. I'm immensely proud and feel enormously privileged to have been a part of it.
Besides the amazing science Cassini returned, just the beauty of this planet, I think, sparks something inside of us.
Whenever I look up at Saturn now, I know that Cassini is there too, and so Saturn is even a more special place.
This summer, Adam Savage takes us beyond the myth.
Holy cow, everything blows to smithereens.
And he's building the most awesomest things ever.
There we go.